to stat, go to ANOVA, go to one-way ANOVA. Response data are in separate column because we have in 3 different columns. Select the second option. Come here, select all the 3 columns. Right? Now you give OK. ANOVA is done. The the factors effect, average effect is indicated here. Now go to the ANOVA table. ANOVA table. This is what we have created now.
Yeah.
But MINITAB has done it, effortlessly. Just we fed the data, it gave. And now see here, looking at the data, this is the hypothesis statement. Everything you can refer here. Whether you have framed it correctly, all that you can cross verify. Null hypothesis written for you. All means are equal. What is mean? Mean transaction time is equal with all vendors. What is alternate hypothesis? One of the vendor is significantly different, maybe higher or lower, and significance level alpha. And then assumption. Whenever you do ANOVA, the assumption is variances are equal. Either you make an assumption or you test the variance also. If you test the variance, it is called Bartlett test. What is that? Bartlett test. There is another equivalent test, Levin's test. Do any one of the thing. Because you have 3 groups. For 3 groups, when you test the variance, it is called this thing. Suppose in certain situation, when you have only 2 groups and you want to test the variance, that will be called F test. That will be called F test or simply called variance test. But what we assumed? We assumed that variance are equal. And now the factors are factor is vendor A, vendor B, vendor C. ANOVA table, we have mastered each and every piece of ANOVA table. And model summary is there. And model summary, tomorrow you will understand. Because tomorrow, I am going to teach all of you tomorrow morning. Generally, I teach it on day 5. But we spent more time on hypothesis testing. So this correlation and regression, I will teach tomorrow along with the DOE. Be ready for it. And this correlation analysis is required to test factor sufficiency. What is that? Factor sufficiency. Right? For example, in this case, model summary, R square is telling you the value is 1.26%. Minimum 80% should appear here. Minimum 80% should appear here to say the factors are sufficient to make the decision. Right? Now it is very, very low. So we will understand the R square tomorrow. And now all that. So the MINITAB method also, MINITAB method of doing ANOVA also understood. Yes. So what happened here is this I mentioned no. What is our assumption while doing ANOVA? Variances are
same. Equal.
If you don't want to simply go with the assumption, you want to do the test, please do it. Go to stat. Go to ANOVA. Go to test for equal variance. Go to ANOVA and then test for equal variance. Now, data in separate column. You select that. And where is the data? 1, 2, 3. Select. Give OK. Now, variance test is conducted. Vendor A varying from this value to this value. Vendor B, this value to this value. Vendor C, this value to this value. Can you see some overlapping here?
Yeah.
Vendor A is overlapping with vendor B from this point till this point. Vendor A is overlapping with vendor C from this point till this point. This overlapping is the error. This error is what we are capturing here. How much is the overlapping? 67% overlapping is there. When 67% overlapping is there, can you say vendor A variance is more, vendor B variance is more? You can't say. So you simply say variances are equal. This is called Levin's test. Levin's test, you see here, p-value is available. When you are checking variance, when the p-value is more than 5%, it means variance are equal. Because when p-value is less than 5%, we'll say variance are different. What is requirement? Variances are equal is the requirement. So p-value should be more than 5%. There are two methods followed. Both method, it confirms that variances are equal. Do you now understand our assumption is correct?
Yeah.
Right. And now one more underlying assumption is the data is normally distributed. Am I correct?
Yes.
So that also you can test. How can you test? Go to stat, go to basic stat, go to graphical summary. Go to stat, go to basic stat, go to graphical summary. Now select all the three columns of data. Now give OK. Three histogram will be generated. This is vendor C. Look at the histogram. Is it looking like a bell shape?
Yes.
That means your eye is very powerful to say that data is normal. This is normal eye test. This test is called normal eye test. But if for some of you, if the eye is having a problem, you are not able to recognize the bell, go for the Anderson-Darling test. Result of Anderson-Darling normality test. Look at the p-value. How much is the p-value?
0.43.
0.4 means data is normal. Because always for normality test, the null hypothesis is data is normal. Most of the time, data will be normal only. You can simply believe, you can simply assume, most of the time you assume data is normal. If you are very confident, you have certain clue, then only you should go for the other distribution. Otherwise, that's why normal distribution is very important, and that is confirmed with the higher p-value. For the second set of data, look at the p-value, again 44%. First data, p-value is 94%. That means the data is normal. The first assumption holds good. Second assumption, variances are equal. That also holds good. Now you are ready to do the ANOVA. So always please remember, when you want to do any hypothesis test on based on normal distribution, first test the normality. Before going for the test of mean, you have to go for test of variance. For 2 group, it is called F test. For 3 group, it is test of equal variance. You can go for Levin's or something. And now the MINITAB method is also understood. Are you all okay now? So what you need to master to say you are a black belt? Only 2 important tools: correlation regression analysis and then design of experiment. That I am going to teach you tomorrow, because I don't want to load everything together. So I have reserved it for tomorrow. And today afternoon, you are going to learn, improve, and control. Is that okay?
Okay.
We learn some more analysis tools tomorrow. And then today you are going to have one case study, a live real-time case study of DMAC. And tomorrow you are going to have another case study. 2 case studies. And then that will complete your black belt journey. And then you will be ready for the exam and ready for doing a project also. We sincerely expect all of you to do one project also as part of the course. But we'll be conducting the certification ahead of the project, but don't hesitate to do a project after your certification, and and that will give you a lot more learning. And we'll be mentoring you on your project also. And it is only after you complete at least one project, we can consider you for the next level of program, which is Master Black Belt. Till then, you can't enroll for the MBB program. So at least, of course, you all have to do project definitely, because that is important, required for your company. At the same time, you also qualify you for the MBB level. And once you become a Master Black Belt, we ourselves will create a lot of opportunities for you to work in the field of Six Sigma. Right? Like you will be considered for empanelment in our training activities. You will be considered for empanelment in our consulting activities, and of course you can also do it on your own. All right, but we have a good network of people. We can collaborate and then help each other, and you can get back all your investment through this collaboration. You understand? You have invested on your time, your money, and a lot of efforts, a lot of patience to learn all those things. You have put in a lot of investment, right? And all those things will start coming back to you once complete the journey at the Master Black Belt level. And we